Hi everyone, this is the last video which is going to talk about the project, and specifically we're going to talk about the paper portion of the project where we're now going to write down everything we've done thus far. So if you watch the first two videos, you've seen almost everything that you would need for the project. So now I'm going to show you how to document all of that, and then we can look at other missing things that we might need to do. So I'm going to go ahead and you can look down at this checklist on the first page. That would probably be the first place I would look. But the next thing you can do is starting on page 2, you can start filling all your stuff out. So what I noticed here is I wrote all the different points that I constructed in the first two videos. I even gave the label of what that actually was. Now, in order to find the coordinate, I'm going to go back to our demo here. And if I need to figure out, let's say I need to find the coordinates of the Grand Ole Opry. So this maybe is not the best way, but the way that I know as of now that is the easiest way to do this is we're going to go to Grand Ole Opry, and you'll see it's right there. So you can grab that. That's the easy part. So I'm going to get to the other ones in a minute. So GT&A, you can see right there. But starting on point J, every other one of these has some sort of title and then some kind of weird notation afterwards. So like John Tune Airport, I need to get the coordinate. Now, as this might come also as strange, that is not the y coordinate. So what we need to do to figure out the point that John Tune Airport is at, right now what I'm going to do is actually just delete this temporarily. I'm actually going to cut it. And then when I click label when it's blank, it actually will give me the coordinate. So the default label when you leave it blank will be the coordinates of that point. So then you can fill that in, and then I'll go ahead and paste my label back in so I need it. So any of these gliders, which means they slide along the parallel perpendicular lines, or the midpoint. So if you want to figure out the coordinate of the nation, same thing. I'm going to Control X to get rid of it, relabel it. It'll immediately pop on with the point so that you can go fill that in on your paper, and then go ahead and paste the label back in as you need to. So that's how I got the rest of these points on here. Number 2, you have to classify two different triangles. Back in video 1, we had created an isosceles triangle by moving around the airport. So I have that here. I have my distances listed, once again, under our distance folder. For our lengths, I had found those 3 lengths back on the first video. So I just merely copied over the work that we did from there, and then wrote down my conclusion of why it's isosceles. Now, I didn't create a second triangle in the demo video, so you will need to create another triangle. So there is more work to be done here. Classifying by angles, I went ahead and used the Pythagorean converse. I just took those 3 lengths that are up there and found my converse. Okay, now this is where we have to do a little bit of work. So for the parallel tunnels, we had decided to do Titans Airport and then the John Tune Airport to the Parthenon. We made those parallel. Now the way that I'm going to do this is I'm going to take the points I got back in number 1, so T and A, and I wrote those here, and then J and P, and I use the slope formula, and I use my calculator. And remember, this may not be exact, but to the nearest 10th or 100th, I got the exact same slope. So since the slope of TA is equal to the slope of JP, both of these segments are parallel to one another. We also created the nations, which was my midpoint. So what I want to do is to algebraically confirm that my point N that I found using the trick I just showed you is indeed correct. So I wrote my initial endpoints, John Airport and Parthenon, and then I use the midpoint formula down here to confirm that this midpoint is indeed the same midpoint that Desmos told me. Now, I do have to do a second midpoint, so I'm not done the project yet. So I would do a second midpoint to conclude or to check off this box. For perpendicular bisector, I identified the 2 segments that I made as perpendicular bisectors. Now we're on within the second video where I do that. In order to prove this, well, we already proved the midpoint because I showed my work above. If you didn't do that, then you'll have to show that work here. I also need to show that the slope of JP and the slope of HN are perpendicular. Now, with these being slopes, or these slopes being decimal values, the easiest way to do this is take whichever slope you want, so the negative 0.44, I flipped it to a positive right away, and then divided 1 divided by that. That's the essential way for us to take the reciprocal of a decimal value. You'll see that I got 2.23, so that does indeed confirm it's perpendicular. And finally, for altitude, we had GM, which was an altitude of triangle TAG, and it went through the Grand Ole Opry point. So to show this, I found my slope, took the opposite reciprocal, once again to confirm that these indeed are perpendicular one another. And then, of course, I confirmed with my sentence down here that it did go through point G, therefore making it an altitude. So the last thing that you need to do is we need to find the total linear distance. So the easiest way to do this, let's go back to Desmos one final time. In my lengths folder, you'll notice I went ahead and did some more lengths. So I went through every single segment that I created. So I started with those initial 3, but you'll notice that I went ahead and did all the others that I came up with and found all of their distances. I copied that back over here, and so essentially to find the total linear distance, you would just add all these numbers together. Now you can do that on Desmos and then write that as its own kind of value and then copy it over, or you could just simply write them all here, grab your calculator and add these numbers together to get that total linear distance. Remember that this will be in miles, so these numbers would actually be, if we wanted to create these tunnels or tracks for your city, this is how many miles total we actually created across the entire city. Reminder that if you did create another segment, so let's say I needed to make that second triangle. Let's say I wanted to connect the nations to Titans. That would be another new segment. So I would have to come down here, and since the endpoints are already defined, we would go distance n, comma, t. And to put that in the distance folder, I'm going to click and drag so that the line kind of shows that it's threaded through that folder. So that should conclude everything that you need to for the project. Again, going through the paper will allow you to make sure you've met all the criteria. And just like me, I now know to finish my project, I would need to create a second midpoint, which I haven't done, and a second triangle, which I just did, so I could fill my work in to finish this project up. Hope these videos were helpful. Please, of course, ask for questions in class if you have additional concerns about your individual project, and have some creative freedom with this. Feel free to try different things, try new things out, and if something doesn't work, there's always the undo button, and don't forget to always save. If that blue save button's up there, hit the save button. Good luck with your project and have some fun with it.